In the next few minutes, you'll see raw ingredients become finished packs through precise weighing, controlled mixing, specialized forming machines, zoned tunnel baking, long cooling conveyors, automated quality inspection, and packaging lines that seal freshness at scale. Every step is tuned for consistency, so each cookie matches the last in size, color, texture, and taste.
The process begins with ingredient receiving and storage. Flour arrives in bulk and moves into silos, while sugar and small ingredients are stored in sealed bins to prevent moisture pickup and clumping. Fats like butter or shortening are handled carefully because temperature affects how they mix and how the cookie bakes. Every delivery is sampled for quality, checking things like moisture, odor, texture, and contamination risk. And each lot is logged so every finished package remains traceable back to its source ingredients.
Next comes scaling and batching, where automation ensures accuracy down to the gram. Flour is metered from silos, sugar flows into weigh hoppers, and microdosing units add salt, leavening, and flavor components in precise amounts. This stage protects consistency because tiny changes in water, fat, or leavening can change spread, thickness, and cracking during baking. Once everything meets target weights, the batching system releases ingredients in the correct order to keep the mixer cycle stable and repeatable.
Mixing is where cookie texture is built. Fats and sugar are creamed first to distribute fat evenly and control how the cookie spreads. Then liquids are added, and finally, dry ingredients bring the dough together. The mixer speed and time are tuned to create a cohesive dough without overworking it, because too much gluten development can make cookies tough. Throughout the cycle, dough temperature is monitored constantly. Too warm and cookies spread too much, too cold and the dough won't form cleanly. So the line holds a narrow temperature window for consistent forming and baking.
For chocolate chip cookies and other inclusions, add-ins are usually introduced near the end of mixing to prevent breakage and smearing. A controlled feeder adds chips at a measured rate so distribution stays uniform across every portion. After mixing, the dough moves into a hopper or transfer system where it conditions briefly, allowing moisture to equalize and the dough to handle consistently. Operators check stickiness, density, and temperature one last time here because stable dough flow is critical before the high-speed forming machines begin.
For drop-style chocolate chip cookies, a depositor portions dough into consistent mounds on a moving conveyor. Portion weight, deposit height, and spacing are tightly controlled so cookies don't merge during baking, and every pack can be counted accurately later. Sensors verify placement while the machine maintains a steady rhythm, drop after drop, creating identical rows that bake evenly. This is where the cookie's final size and uniformity are locked in before heat ever touches the dough. Filled cookies require synchronized dosing of two components, an outer dough layer, and a measured filling, such as chocolate, cream, caramel, or fruit. The forming system wraps dough around the center and cuts portions to exact weight, aiming to keep the filling centered so it doesn't leak during baking. Filling viscosity and temperature are controlled so it flows smoothly and doses consistently. Cameras or sensors can flag thin shells or miscentering early, preventing waste and protecting uniform quality.
Sandwich cookies start as two matching shells that must be crisp, flat, and identical for clean assembly later. Rotary molding or cutting creates uniform shapes and embossed patterns, while thickness settings keep moisture removal consistent in the oven. The factory watches shell flatness carefully because slight warping can cause misalignment and messy edges during creaming. By standardizing the shell first, the line ensures the final sandwich looks clean and stacks well in packaging.
Crisp biscuits are commonly made by sheeting dough into a uniform thickness and cutting shapes with rotary cutters. Thickness tolerance matters because it controls bake time and final crunch. Thicker pieces can retain moisture and soften inside the pack. Excess dough from cutting is recycled back into the feed in controlled ratios so the dough remains consistent. The result is a clean-edged biscuit with a uniform profile designed for snap and shelf stability.
Baking is controlled by zones. Each section of the tunnel oven has its own temperature and airflow profile. Early zones set structure and start expansion. Middle zones drive out moisture, and final zones build color and finish texture. Belt speed ties everything together, matching heat exposure to the cookie type. Softer drop cookies balance set edges with a controlled center, while biscuits and sandwich shells bake drier for crispness. Stable oven settings are a major reason factory cookies look and taste consistent across long production runs.
Packaging is where freshness is sealed and counts are finalized.
Drop cookies may be stacked into sleeves and flow back, while chocolate cookies are often sealed. Sandwich cookies typically pass through a clean then a top shelf is lined shell on the edges to fill out. Across all formats, barrier that splits the inside from outside. Gate filters apply to red lines. Trace fillers. Cartons are filled, sealed, and hot. Linking them back to batch codes of production. Finished goods move into dry storage, controlled conditions, protect texture, prevent chocolate from melting or blooming. Orders are then picked, staged at loading docks, and loaded for distribution, completing the journey from raw ingredients to retail-ready cookies.